So for this video, we're going to talk through measures of dispersion and position. And so this is 12.3 and 12.4. We're going to start with this example. We have these two data sets. The one on the left here is the hold time, the average hold time for 100 customer service calls to Buccaneer Cable Company. The second set is the average hold time for 100 customer service calls to the Chanticleer Cable. And so both companies have the same average wait time of 5 minutes, and their prices are the same. But if you knew you had this data set in front of you and you were trying to choose between Buccaneer or Chanticleer Cable Company, which would you choose? So the fact that in this first data set, the majority of the calls are in that contained in that bar, basically, you know what to expect. There are lots of calls all over the place here, so you wouldn't really know what to expect when you call. When you call Buccaneer Cable Company, you expect to be in that largest bar. And so that's what you would choose, is the Buccaneer one, because you know what to expect. The results are less spread out. Okay, and then we're going to use that and talk about a couple different ways to talk about a couple different ways to measure spread, basically. So think about, I have this student made up in my calculus class and my statistics class. In calculus, this student has scored a 77, an 80, an 83, a 90, and a 95 on some homeworks. And then in stats, they scored a 61, a 69, an 84, a 95, and a 96. So which set of scores would have a bigger measure of spread? So the calculus scores, the smallest one, or the largest one, is a 95, and the smallest one is a 77. So that spread is equal to 18. And then in stats, their highest homework score was 96, but their lowest one was a 61. And so the spread there is 35. So this is a much bigger spread. And then what about, we want to take that and sort of define it better. So we are going to fill in a table here, and so I'm going to tell you what to put in here. You're going to put X bar, that's the average. And so to find the average, you do X bar is you're gonna add all those scores up: 77, 80, 83, 90, and a 95, and then divide by 1, 2, 3, 4, 5, by 5. That's an 85 average for those homeworks. So we're going to put 85 in all of these spots in this table. And so what we're going to actually do is figure out, okay, so how far from the average are these scores? So what's the difference? So do 77 minus 85, and that is -8. So it's 8 below the average. This one's 5 below the average. This one's 2 below the average. This one's 5 above the average. And this one's 10 above the average. Okay, so this next, all of that should probably have made a lot of sense why you would do it, how far from the average or your scores. So this next thing that we're going to do is a little bit different. What we're going to do is take that difference and square it, and some of that's because we don't necessarily care if it's above or below that average, just how far from the average it is. So to take care of that, you square it, because that'll get rid of the negatives. So 64, 25, 4, 25, and 100. And we're going to average those to come up with what the spread is of the set. So average all those up, or add all those up. So do add up differences squared. And you get 64 plus 25 plus 4 plus 25 plus 100. and that is 218. And then what you're going to do is then average those, sort of average. So you're going to do 218 divided by n minus 1. So this is to actually correct a bias because we're using a sample mean instead of a population mean. So you're going to divide by n minus 1. In this case, that would be, let me go up here, 218 divided by 4, which is 54.5. Okay, so that is called the variance. That is the variance in this data set. So the notation is s squared, and it's given by this, that's a sigma of x minus x bar squared over n minus 1. So this is actually what we just did in that table. Let me do this in pink maybe. So this is x minus x bar. This is x minus x bar squared. And then we added all of those up and we divided by n minus 1. And that's what this notation and this notation means. That's all. So the variance of our data set is, for us, it's s squared equals 54.5. Okay, so this formula into a list of step is, that table is a great way to do it. So you're going to think about order of operations, find the mean, then figure out how far each value is from the mean. So do x minus x bar, then square that difference, then add up all of those things, and then divide by n minus 1. And that will give you the variance. So we will do an example at the beginning of class, but this explains sort of why, the motivation behind doing it. So if you have any questions, let me know.